All right. So let me explain this to you, okay? Like it doesn't necessarily just have to be a square root. It's best if you understand what's going on here.
Yeah.
So for something to be a function, it needs to pass the vertical line test. Now, how do we determine if something passes a vertical line test? Look at question 4. This is a linear equation, okay?
Hmm.
How do I know this? If you move x and y, you get y is equals to minus x plus 12. This is in the form of mx plus b, where the slope is -1 and the y-intercept b is 12, yeah?
Yeah.
Linear equations are always a function.
Hmm.
Okay, let's look at 1, y equals square root of x minus 4. Now that is a square root function that has been transformed 4 units right. So a square root function looks like this, starts from the origin. This guy has been translated 4 units to the right. So instead of starting at 0, 0, it's going to start at 4, 0. So it's going to look something like this. So this is a function as well. Okay, what about 3, this one? What do you think?
So would that be the slope, the 2?
You know, this is not a linear, right? See, in a linear, everything is power 1, okay?
Okay.
X is power 1, y is power 1 here, y is power 2, so that is not a linear. What we can do first is solve for y, okay? Let's solve for y. How do we solve for y here?
We would square root x.
No, you first need to divide it,
Divide by 2. Yeah, sorry.
and then
And
you
then
square it, okay?
square root. Yeah. So
So
x
at
over
this
2.
level, whenever you're square rooting it, it's always going to be plus minus something, because the square root of 4 is 2, but it is also -2, because -2 squared is also 4. So whenever you're
Oh,
square
okay.
rooting something, it's always going to be plus minus, okay?
Yeah.
Now, if you look at this function, excluding the plus minus, this is again a square root function, okay, that has been horizontally stretched. Now, how do I know this? Well, you need to kind of remember this. We did this in grade 11, like for transformations. Every transformation has this rubric: a, f the function, k, x minus d inside the function itself, plus c. Now, if you notice, k is what's multiplied with x inside the function, right? So over here, you're multiplying the x inside the function with 1 over 2, right?
Yeah. And then what's this equation used for? Sorry.
This is for transformations.
Okay. X minus d.
So A is vertical stretch or compression, yeah?
Yeah.
K is horizontal. Everything inside X lies. Horizontal stretch or compression, okay?
Hmm.
Now notice inside you have 1 over 2. You'd expect it to be a horizontal compression, but since X lies, K lies, this is a horizontal stretch by a factor of 2.
Okay.
Okay, so we know this is a square root function. That's fine. Square root functions are a function. But here's something else is going on. If you notice, there's a plus minus element on the outside. Now, what does that plus minus do? Plus does nothing. Plus is the original one. So this will just be something like this. This just be the original function that has been horizontally kind of stretched. It's gotten fatter. Okay. This plus minus, this gives you two different equations. Now, y is either equals to plus 1 over 2x, or y is equals to minus 1 over 2x. Okay.
Mm-hmm.
So this gives you two different equations. Now this one that we have over here, this is the plus one. Now if we do the minus one, it's going to flip on the x-axis, so it's going to go downwards.
So it fails the vertical line test.
Exactly. Individually, they are both functions, but when you combine them like this, in this case, this is not a function. 3 is not a function. Okay. What about 2?
And but
Yeah.
how do you know that that's how that graph would look based on that equation?
Because I know what the parent function looks like, okay? Like that. That's y equals to the square root of x. Now, this horizontal stretch by 2, it just means it's gotten wider horizontally, like thicker. Okay.
Oh, okay.
And how do I know it's gone upside down for the second one? Because here a value is negative, right? Whenever a is negative, it flips upside down. If a is negative, it flips upside down.
Okay.
Like minus x squared, right? That's a is negative here. So instead of the parabola going up, it's going to go upside down like that.
Yeah. All right.
Okay, what about 2? Is this a function?
2x squared plus, is that plus minus 3?
Yeah, it is plus minus. So it has two different equations, right? Again, it has either x squared plus 3. What does that look like? That's just the parent function x squared translated up 3 units. So this is the parent function. And x squared minus 3 is the parent function that's been shifted 3 units down. So there you go. This is going to be x squared plus minus 3.
I mean, that would pass the, well, if you're excluding one of the two functions for each point, like the vertical line test, then it would pass. But if you're including them, then it would fail.
Yeah, it would fail. So for y, it fails, right? Because you have to include both of them.
Okay.
Y is both the top graph and the bottom one. So here y is going to fail the vertical line test. So this is not a function.
Mhm.
Cool. So that's that question done. What's the next one?
Next one is 13, I believe. Yeah, 13.
Find the domain and algebraically and support your answer graphically. Oof, this one's going to be tough.
To find the domain, don't we need to set that equal to negative x, the denominator?
No, you set it equal to 0.
Equal to 0. Oh yeah, so
So you cannot have a 0 in the, but what we can do here is we can take out an x and we can factor this. See here?
so g of x equals
X over x minus 5. I just pulled out an x from the denominator, yeah?
5x.
Now what's going to happen here is that this x is going to cancel out with this x.
Minus 5. Yeah.
So this function is
this
going to
becomes
reduce to 1 over
1
x,
over x
minus 5. Okay. And now you set this denominator equal to 0, and that'll give you what x cannot be. That'll give you the vertical asymptote.
It can't equal 5.
Yeah, exactly. So at x equals 5, it's going to be a vertical asymptote.
Mhm.
But there's
So-
something else here, though. Like this is from advanced functions. You see both x's canceled out.
Yeah.
So the question is, for what value of x is this function undefined? Okay, what do you think? 5 is one of them. What about the other? There's another one. If x were to be something, we would not be able to cancel this.
Infinity?
0.
No.
0.
0?
If you have something
Oh,
0
you
over
can
0,
have 0 in the denominator. Yeah, you can have 0 in the denominator.
so x can also not be 0.
Yeah. Okay.
Now, what does a graph of this look like? So you need to remember this. The parent function, what's the parent function here for the reduced guy?
1 over x.
Yeah, 1 over x, right? So what does that look like? It looks something like this, okay? But now you see minus 5 in the denominator. This is transformed. It's transformed 5 units to the right. Okay?
Yeah. And again, like, I'm wondering, like, how do you, obviously, you know the parent functions, you probably memorized them.
Yeah.
But like, how would you be able to always, if you don't, say you forget somehow?
There's only 7 of them, so you kind of have to memorize them.
Okay. Could we go over that after, just because I kind of forgot, like.
Yeah, so here, there's the linear one, right? Y equals mx plus b. That is a function. This is the linear one, looks like this. We can just do it right now on the side. And then there is x squared, the parabola, looks like this. And then there's y equals, what else is there? The absolute value of x, which looks like a parabola, but instead of curved, it's like straight lines. It's like a V. And then there's y equals to the square root of x, which looks like this. There is y equals to this guy that we just did, 1 over x, which looks like this. And then there's y equals to 2 to the power of x, which is like exponential functions. That looks like this. The 7, 1, 2, 3, 4, 5, 6. What are we missing? We're missing the logarithmic function, which we'll do when we get to the log unit. It's a little bit more complicated, but these are the basic ones.
2x.
2 to the power of
Okay.
x.
Oh, 2 to the power of x. Yeah. Thank
So
you.
what does this one means? It's just translated 5 units to the right. So here, x cannot be 0, right? There's the asymptote, but here x cannot be 5. So this function is going to look something like this, okay? But now here's a very important part. This is from advanced functions. See, x also cannot be 0, yeah?
Mhm.
So when x cannot be 5, right, in the denominator here, that will give you something, whatever is the numerator, doesn't really matter. You'll get a 0 in the denominator, only a 0 in the denominator, yeah? So when you get a 0 in the denominator, it's a vertical asymptote. That's why we have this dotted wall here at 5. But when you have a 0 in the numerator, as well as a 0 in the denominator, okay, you get something called a hole in the graph.
So, okay. 0 and over 0 equals hole in the graph.
Yeah, so you'll add, when x is 0, you'll have a literal, like a hole in the graph. It'll be an open circle when at x value of 0, whatever that is on the
Yep.
graph, there'll be an open circle.
Sure.
The question's asking us for the domain, right? So here x
Yeah.
cannot be two things. So you can just say x is a set of all real numbers, and x cannot be 0 and positive 5.
I think they want us to write it with square brackets and parentheses. That's how we were taught.
All right, cool. So then you would do minus infinity to 0.
Yep.
And then you go from 0 to 5, all normal brackets, and then 5 to infinity.
And why is it negative infinity?
Because that's all, you always start from the least possible number, which is negative infinity.
Okay. 5 to infinity. So that's saying it can't equal those things.
Oh no, this is a domain. It can equal these things.
Oh, it can equal these things. Okay.
Yeah.
Yeah.
That makes sense?
Yeah. The next one is 17 and then 21.
Now this is asking you for the range of the function. This is a little bit easier, I guess. I guess that's relative. But this one's a quadratic. So this one, we've been doing this from grade 10.
Mhm.
What do you think the range of this function is? By the way, the domain for a quadratic is XCR. The domain for a linear, okay, XCR means negative infinity to positive infinity. For quadratic, x squared is negative infinity to positive. It can be anything. What else? For this guy, the absolute value function, negative infinity to infinity, XCR. These all mean x can be anything. These are all the domains. What else has a domain of XCR? 2 to the power of x, negative infinity to infinity.
Okay. That's just saying it can be basically any number.
Yeah, any number you can think of, yeah.
Okay.
So the domain of this is XCR because this is a quadratic, right? X squared. The question is asking us, what is the range of this function? So it's asking us what are the possible y values this function can take.
Okay. So do we make y equal to 0?
If you make y equal to 0, you would get x-intercept. That won't help you here. You just need to kind of think of this, okay? Here, let's rewrite this to make your life easier, okay? To make our life easier. We're going to write this in a form that we are accustomed to, like this. Okay, what is the parent function?
Okay, the parent function is x squared.
Yeah, so that looks like a u, right? That's a parabola, goes through the origin, right?
Yeah, and there's a reflection on the, would that be y or x? That would be y?
X. So
That'd be
flip
the
upside
x-axis.
down. Yeah, that's the A value. It's a
And it's up
reflection
10
on
units.
the, yeah, exactly. It's a reflection on the X axis because this minus sign is outside the function. If it was like this, you see now the minus sign is inside the function, yeah? Then it'll flip on the Y, but this minus is outside.
Okay.
Like for example, minus 3x in a square root. See, this one is a reflection on the y-axis versus if you have the minus sign outside the function, outside the parent function, the square root, right? This is a reflection on the x, this one's a reflection on the y, okay?
Okay.
So we know this quadratic looks like this and has a value of 10. All right, look at the graph. What are the possible y values it can take?
10 to negative infinity.
Yeah, there we go.
Wait,
And
but
actually,
don't you square bracket one of them?
yeah, 10 is going to be square bracket because it can be 10, right? Before it couldn't be 5, but now it can be 10. So you put a square bracket.
Okay, wait. Let me just. I just need to get this down, like the graph down, so I can remember. Yes. Like 10. Yeah, because the parent function. X squared plus 10. So x squared equals pf. Right. All right.
All right, let's move on to 21. I
21.
think.
Yeah.
What does it say?
The square bracket means it's included, right?
Correct. Yes, it means y will be 10.
But why would like negative infinity not be included? Because it's undefined.
Yeah, exactly. Infinities are always in a normal curved brackets. Always.
Okay.
See, that's why we have all these in normal brackets.
Yeah,
Infinities
and any
are
other
always,
value?
yeah.
Any other values in square brackets?
Not necessarily, but if it's inclusive, yes. Like if you look at the 2 to the power of x, right?
Mhm.
So while the domain is XER, okay? Now what's the range? The range for this function is 0 to positive infinity. It'll never go below 0 on the y-axis, but 0 is not inclusive because there's no value of x that would make this equation true. So you see inside of a square bracket here, this is a normal bracket because 0 is exclusive. It's not included.
Okay, so for like asymptotes and stuff like that, there would be like, I get that.
21
Yeah.
says graph whether or not it has a point of discontinuity. So a function is discontinuous if you have to lift up your pen when you're graphing it. And what do I mean by that here? Quadratic, you don't have to lift up your pen, right? One stroke, that's continuous. Linear, one stroke, yeah? But this guy, you see there's, if you look at the parent function, there's an asymptote in the middle, right? So this is discontinuous.
Okay. And the 3, what would the 3 do?
It's a vertical stretch. Vertical stretch.
Vertical stretch.
Yeah, if the 3 was in the denominator, it'll be a horizontal compression, but 3 is in the top, so it's a vertical stretch. So this just becomes like taller in a sense. The graph would become 3 times taller.
Okay.
And since there's an asymptote in the middle, it's going to be discontinuous.
Okay.
That makes sense?
Yeah, I'm just yeah. All right, I'm good. Yeah.
What's the next one?
The next one is 25.
All right, here. So these are both higher powered function. This one is x cubed. This one is x to the power of 4. So something you should know for these higher power function is they have a bunch of turning points, okay? Look at this value. Let's look at this point. Is there a y value that is higher than this point?
Yes, it's a local minimum. We learned about this in class.
So this is a local minimum?
Or maximum, sorry.
Yeah, this is local max. What about 5, 5?
Isn't that the absolute max?
Yeah, that's the absolute. What about 2, 2?
would that be the local minimum? Or
Yeah,
would
exactly.
that
It'd be local minimum because there are other values here that would
those
be lower
variables?
than this. So this is local min. They're also asking you identify the intervals on which the function is increasing and decreasing.
So wait, what do we have to do for this question? Next says 25. State whether each labeled point are definite, okay, or neither. Identify intervals on which the function. So do I have to replicate these graphs?
For the second part, no, you don't. You just look at this, right? So when x is less than 1, is this function growing or like going down or going up? The y values.
It's going up.
It's going up. So that's an interval of increase. So increase, you have negative infinity to -1. That's one of them, right? But we're not done. What else? Where is it increasing? Look at this, from 2 to 5 on the x. Yeah, it's also increasing. At exactly 2, it's 0, so that doesn't really mean anything. That's why these don't have square brackets. Okay.
So the first one, -1 and 4, you're accounting for the y values, right?
Yeah. So the interval of x values when the y values are increasing. So up until -1, right? X values, because this is going to go all the way down there. You see, as the x values go up, the y values go up.
Yeah. So
From
negative infinity x values.
Yeah. So from negative infinity to -1, or in the other notation, this is like this: x is less than -1. The function is increasing.
And wouldn't that -1 be inclusive?
No, it won't, because at exactly -1, the function is doing neither. It's not increasing, it's not decreasing either. It's a turning point, right? So the slope there is 0. You see, this is a horizontal slope there. The tangent, you know what that is? Tangent. The tangent is
Yeah.
horizontal.
And why would that be negative infinity x values? Because the x values are defined at -1, aren't they?
What does this mean? This means, see this, what does that mean? That means when x is less than -1.
Oh.
So when x is like -10 million, the function is increasing. When x is -1.01, the function is increasing.
Okay.
Okay, and where is it decreasing? Tell me for 25.
It's decreasing in, well, the 5 and 5, right? 0.5.
Yeah, but we need an
0.5.
interval though,
Okay.
between some x values, 2 different x values.
Okay, so wouldn't it be 5 and positive infinity?
Yeah, good, that's one of them. There's one more place where it's decreasing.
Oh, also, yeah. -1 to 2.
Yeah, there's a decrease, it's going down, yeah?
Yeah.
There we go,
Okay.
that's the whole question. Here it says neither for one of them, right? Are there any neither in either one of these graphs? Max, min, or neither?
No.
There is. You see this 3, 3?
Yeah.
That is neither. It's not a maximum, it's not a minimum. This is a local min, this is a local max. Okay, why is that? Why are both of these locals? Because there are y values that'll be less than this. There are y values on the here that'll be greater than 7.
But
Okay, so
they're not defined on the graph, but they will be.
yeah. But 3, 3 is
Okay.
not a minimum, it's not a maximum either.
And what's B the notation of?
D,
Like you
D
put
is
B.
decreasing. D, this is not B, this is D, decreasing.
Oh,
Increasing, decreasing.
yeah. -1 to 5 to infinity. Right. Okay. And then do we have? I don't think we need to do 26, but
No, we
just
did it
see.
anyways. We don't need to, yeah.
Yeah. Okay. The next one is 29. I think. Let me just check. 29. Yeah.
I can see more transformations here. So what does this function look like? What's the parent function?
Okay. The parent function is absolute value of x.
Yeah, so that looks like a v, right? What has happened to the parent function?
It has, well, the c value is -1,
Uh-huh.
and it's gone up 2 units.
Nope.
Or sorry, it's gone down 1 unit and 2 units to the right, or to the x y's. So
Plus
the
2 means it's
left,
going
to
left.
the
Yeah,
left, to the
exactly.
left.
Yeah. So before our vertex, you see this point where they converge. That was 0, 0, right? So now we've gone 2 units left and 1 unit down, right? So -2 and -1. There we go. That's our new vertex. Okay.
Mhm.
And you don't really have to be precise here. You just need this point, and that point is -2, -1. And our function will look something like this.
Okay. And then it says identify intervals on which the function is increasing and decreasing. Okay. Do you have to be exact with this?
Yeah.
-2 and 1. It begins. Okay. So, all right. It's decreasing. Well, should I start with decreasing? I guess.
Yeah, this is
From negative infinity to -2,
yeah.
and it's increasing from -2 to positive infinity.
Yeah, exactly. And it's constant when x is 2.
Yeah, let me just get this down. X plus 2 minus 1. Parent function equals absolute value of x and x also. So this shifts a bit. So it becomes -2 and -1. Increasing. Decreasing. To -2. And then constant. What's constant?
Constant mean where the slope is 0. So at this point.
When the slope is 0. Okay. Okay. Slope is 0.
So every turning point, the slope is 0. Okay. It doesn't matter if it's curved or if it's like pointy, you see? Like something like this, right? This is like, see all these points, the local mins
Yeah.
or maximums, all there, the slope is 0. It's neither increasing nor decreasing, it's constant.
Okay.
Cool.
Yeah. The next one is 31. No, 37.
What does it say? If it's bounded above, bounded below, or
Oh
bounded
yeah,
on its.
this is easy. I know this. Y equals 2 to the power of x. You showed me how this looks. 2 to the power of x. Okay. So the parent function, yeah, you can graph that out. It's literally just the parent function. So it would be, it has a floor, which means it's bounded upwards.
Yeah.
The domain would be, yeah, negative infinity to positive infinity. It wants us to find domain too.
No. I'm just writing that down. Just to show that goes for infinity. Like it's never gonna bound below. So there's like an asymptote here at y equals 0. There's an asymptote.
Yeah.
So it's bounded above.
Mm-hmm. Okay. That one's a pretty easy question.
Mm-hmm.
So 41.
It says use a grapher to find all of the local maximums and minimums. What does a grapher mean? Like a graphing calculator, like Desmos?
Oh yeah, no, I have a graphing calculator after. She showed us how to do this. But it's tough. Like I don't
Yeah,
know
I
if
don't
I'm
I
gonna
don't like
get it.
graphing calculators. They're so slow.
Yeah. So I have to do
I'm just gonna put this on Desmos and cheat. Actually, you can get a Desmos app on your phone. It's so
really?
much faster than the graphing calculator, no joke. But you're not allowed to use your phone. It's just for your assignments and whatnot.
Mhm.
Like just for your understanding. So you put it on your graphing calculator. I don't know which one do you have, TI-84?
Yeah.
Yeah, you know that thing has not, it's been the same for the last 20, 30 years, man. They have not really upgraded it.
Really?
It's so slow. I don't like it. I had to use it as well back in my day. I hated it. But it has a lot of functions. Like it does stuff for you, but it's very slow.
Yeah. I don't love it so far. So
Yeah. It says find all the local maximas and minimas and the x values where they occur. So super simple. There's only a local minimum here. Yeah.
and
It's not this, that's the whatever, that's the y-intercept, but this point right here. So that's the local minimum.
Mhm.
And the x
The
value
maximum.
that's it's not a local maximum, it's a minimum, right?
Yeah, I know. I don't think there is a maximum.
No, it does not. Yeah, there's none. So at x equals to 0.5, there's a local minimum, and that's the question. It's pretty straightforward if you can graph it.
So local min equals x is 0.5. Okay. And then the next question is 53. G of x equals 2x to the third minus 3x.
So here, when it's asking us to determine whether this is odd, even, or neither, okay? And it's not asking us for the degree. It's asking whether g of x is an odd function, even function, or neither. So how do they work? For an odd function, right?
Yeah, let me just write this down. Okay.
For an
Yep.
odd function, whatever you have down there, you'll have up here.
Okay.
So if
So
you
odd.
think of this as quadrants, right? Quadrant 1, 2, quadrant 3, quadrant 4. For an odd function, quadrant 3 and quadrant 1. It's a reflection about like the origin, basically, like this way.
Okay.
For an even function, it's like x squared. It's much easier. It's just a reflection on the y-axis.
So even is a reflection on the y.
Yeah, but this is not a reflection on the this is not a reflection on the x, okay? This is a reflection about the origin, you see?
Okay.
If you did a
Yeah.
reflection on the x-axis, then you would get this one, but that's not how odd functions work. This one, though, is a reflection on the y-axis. That is it graphically, okay? And when you're doing it algebraically, there are rules. For odd function, if you put a negative x in there, that negative sign literally comes out of the function.
And when is it neither? Sorry.
It's neither when it does not satisfy the conditions for odd or even. So this is the algebraic condition for odd. For an even function, the condition is this. Okay, here, notice the difference. Here we put in a negative sign, the negative sign comes out of the bracket. Here we put in a negative sign for an even function, the negative sign completely disappears.
Okay, so you're starting with the right side and then solving.
Yeah.
Right.
So
Okay.
here, they've given us g of x. Did you get this down?
Yeah.
Okay, now we're gonna find g of negative x, and that will give us the answer, whether this is odd or even, right? So tell me, what is g of negative x gonna be? G of
Okay,
x is
so
this function.
to solve what are these called? You have to make it negative x, right?
Yeah.
To solve I don't know what these are called, odd or even.
Yeah.
Set x to negative.
So what would you get? We would get 2 times negative x cubed, yeah, minus 3 times negative x. Like that?
Yeah. Mhm.
Okay, let's open this. And again, negative x squared is just negative x cubed, sorry, is just negative x cubed. So you get minus 2x cubed plus 3x.
2x cubed plus 2.
Now what I'm
Yeah,
gonna
okay.
do is take out a minus sign from this function. What's in the bracket?
The bracket has 2x squared minus 3x.
No, plus 3x, because we took out a negative sign.
Oh, wouldn't that? Okay, sorry.
Yeah, so if you throw this back in, you would get this, right?
Mhm, mhm.
Actually, you were right. This would be minus 3x, my bad.
Yeah.
Yeah, so when you throw the minus sign in there, you should get the previous step, and which we do. Yeah, so there's a minus in there. Now notice, what is this? This is g of x, so we got minus g of x.
Minus g of x.
So it satisfies
With
this condition. So it's an odd function.
g times minus x. Oh, so minus g of x is the same as g times negative x.
Yeah.
Okay, so for it to be odd, it's got to be g times negative x. And for it to be even, the condition is
This one, the negative sign completely disappears. So for example, try plugging it in this one. So let's say this is your g of
oh, so
x.
the condition would just be g of x, like your final answer would just be
Yeah, exactly. The
positive.
negative sign completely disappears. You'll start off with what we did here, right? But your
Yeah.
final step, the negative sign is completely gonna get eaten up here. If we plug
Okay.
negative x in here, right? Here, check this out. When you're taking an even power of any function, right? Any variable, it eats up the negative sign. So you see, we get what we started off with.
Yeah, because negative times negative is
Yeah,
positive. But
exactly.
when it's odd, you still have that negative.
Yeah. So this one would be an example of an even function. This
Yeah,
one's
sorry.
odd though.
I got to copy this down, just the example. To
You can call it something. You can call this g of x, and then here we will do g of minus x, which you get this, and then we get g of x, the original thing. So that's why this is an even function. And if it doesn't match either of these conditions, then it is neither odd nor even.
And what would that look like?
That just looks like a unsymmetrical, like asymmetrical. What's the thing for symmetry? Like something like this. See, nothing here is here, then this is not a reflection on the y-axis either.
Yeah, but like algebraically, what would it be like?
Oh, there's no algebraic condition. It's just if it doesn't match either one of these, then it's neither. You check for
okay.
both. If it's it doesn't match, it's neither.
Negative 2x cubed plus 3x. And then you take that minus out right there. It becomes 2x cubed minus 3x. Which satisfies that condition. Unless it's odd, right? Yeah.
53 is odd. This example is even.
Yeah. 53 is odd. Okay. Yeah. The next question, I think it's 57. Let me check. Yeah, 57.
Find all horizontal and vertical asymptotes. All right, so either you can you can have two more things. All right, you can have either a vertical asymptote, and what's the condition for that? Vertical asymptote, I'm just going to label it VA. Okay, vertical asymptote. This is, you just set the denominator equal to 0. Denominator.
Just define the vertical asymptote?
Yeah, you set the denominator equal to 0.
Find VA, set denom equal to 0. Okay.
So we have 3 minus x equals 0. So what is x?
X is positive 3.
Yeah, there we go. So that's our asymptote, x equals 3.
Yeah.
That one's simple.
Oh, okay, so that's here. Yeah, sorry. I have a formula sheet that I'm going with right now and a question sheet. Put the wrong page. Oh, here we go. Okay, 57 g of x. And yeah, we just set this to 0. X plus 2 over e minus x. And then it would just be 0 equals e minus x. So x equals 2. Okay. And that would be the VA.
Yeah.
Right?
Now for horizontal asymptote. So this one, there's a few conditions for this. Horizontal asymptotes, there's 3 different conditions, okay? We look at something called the degree of the polynomial. Here, let me explain to you what a degree is. It's a simple idea. It's the maximum power. You see x3 plus 2x squared plus 6. The degree of this polynomial is 3.
It's the highest.
Yeah, it's the highest power. Exactly. X plus 1, the degree of this polynomial is 1. Okay.
So to find HA, consider
Find the degree. Okay. And now once you know the degrees, right here, they're both 1 and 1. There's 3 different conditions for this. Condition 1, where the degree in the denominator, is greater than degree in the numerator. I didn't spell that right, but numerator. Okay, this is one condition. Doesn't apply to this, but when this happens, there is a horizontal asymptote at y equals 0 every time.
Horizontal asymptote at y equals 0.
The example here. See, the degree in the denominator is 2. The degree in the numerator is 1. Degree in the denominator is bigger, so this one will have a horizontal asymptote at y equals 0.
Okay. Second condition.
Second condition, when they're equal, when the degree in the denominator is equal to the degree in the numerator. So for example, 3x plus 2 over 5x minus 8 or whatever, okay? See, both of them have degree 1, right? X is power of 1. Yeah?
Yeah. What happens when they're equal? Sorry.
So when they're equal, the horizontal asymptote is at the ratio, is at the ratio of the coefficients of the leading power.
Is at the ratio?
Yeah. Of leading powers, of leading coefficients, the ratio of leading coefficients.
And what is that like?
So x is the degree, the thing that determines the degree, right? What's the coefficient of x? It's 3. On the denominator, it's 5, right? So the horizontal asymptote would be 3 over 5. Y equals to 3 over 5.
Oh, it's just, okay. It's just the things that.
Yeah.
Okay. So example, this would equal 3 over 5. Okay. And then is there a third one?
Third one is the more complicated one. I don't think the question's asking us for it, so I don't think you need to worry about it, but I'll tell it to you anyways, okay, for your knowledge. Now, we haven't done when the degree in the numerator is bigger, yeah? So there will be no horizontal asymptote here. So when the degree in the numerator is bigger than the degree in the denominator. For example, x squared over x plus 1. There is no horizontal asymptote. But there is a different kind of asymptote, which I don't think you've heard about. Maybe you have. It's called oblique asymptote.
No.
Yeah. So you see vertical and horizontal, they're either like up, down, left, right, yeah? This oblique asymptote thingamajig is slanted. It's in this direction.
So basically just diagonal.
Yeah.
Okay.
So this does not have a horizontal asymptote though, but has an oblique asymptote. And to do this, you have to do long division. to find out what the asymptote is.
Long division.
Yeah. So for example, you do the long division here, right? X plus 1, long division x squared. Have you ever done something like this?
I don't think so. No.
Yeah, I'll show it to you how to do this just for your interest. We need an x squared here. Okay, so what's the idea in division? You always want to subtract the exact same thing that you have in this bracket. In this is called a dividend in this guy. Okay, we have x. We need x squared. What do we need to multiply x with? Just x, right?
Yeah.
We want x squared. We have x, so we multiply x with x squared. So now look at this. X times x is x squared. And then plus 1 times x is plus x, yeah?
Yep.
So x squared minus x squared, nada. And then there's like a 0x here. So the remainder would be minus x. Okay, you see this guy up here? This is your oblique asymptote. Y equals to x. So this is basically the linear line.
Okay.
So you first make this linear line, and then this graph of this possibly looks like this here. It's weird, but it looks something like this. So at -1, it's undefined, right? I saw this -1 in here. There's a vertical asymptote for sure at -1. So the graph of this would look something like this.
Okay.
Okay, and that's called an oblique asymptote. So here, tell me, what is the, so we already know the vertical asymptote is x equals 3. That was easy. What's the horizontal asymptote for 57?
For 57. Okay. The powers are equal to each other, right?
Yes. So this is condition 2.
Yeah. So that means the ratio of the leading coefficient.
Yes.
Would just it's just 1/1. So it'd be 1.
No, -1. The leading coefficient of this is -1.
-1. So 1/-1.
Which is just -1, right? So your
-1.
horizontal asymptote is at y equals -1, and our vertical asymptote was at x equals 3, right? So when x is 3, there's a dotted invisible line. When y is -1, there's a dotted invisible line. And the graph of this, it would look something like this.
Okay, yeah, that makes sense. Finally, getting back into it now.
Back into the groove.
We did 57, right?
Correct.
So now we have to do 71 to 76.
True or false? The graph of f is defined as the set of all points where x is in the domain of f. Justify your answer.
Functions. Graph of function f is defined as set of all points. X in the middle domain f. Justify your answer. What? I don't know.
So here, this one, y squared equals x. Okay. If you look at this, we're going to solve for y. This will basically be our f, right?
Yeah.
So x is in the domain of y, but notice there's a plus minus element to this. Okay. So that means you're going to have this, you're going to have this, and that is not a function. So this is not true. You can have any x value that's in the domain here, right?
Yeah.
But that does not mean the y or the f is a function, because it's going to fail the vertical line test.
Okay. Okay. So this one's false.
Is that what this means? So it's are we assuming it's already a function?
The graph of function f is defined as set of all points.
I think it's asking, given that it's a function, I think that's what it's saying. Right? That's what I'm getting out of it. It's a little confusing.
the wording's unclear to me, but I don't know.
Then I think that'll be true in that case. If we're already assuming or the f is a function, then this rule doesn't apply to it, then it'll be true. Okay? Not sure. I think this would be true. Okay, if you're assuming it's already a function.
Yeah, so okay. How do you just make examples of potential functions that could
Yeah,
be?
yeah.
That's a function. What does it mean, the set of all points?
It's made up of the points, okay? As long as x is in the domain. As long as x can exist in that function, it'll be made up of these points. I think it's true. If we're assuming it's a function, then that has to be true.
Okay.
I'm gonna go with true on this one. Example would be x equal y equals x squared, and as long as x is in the domain, then this is a function. Well, it's already a function, but x will be in the domain of this.
Yeah, because could you make a function that didn't have x in it?
No, you can't. This is true. Let's look at 72. A relation that is symmetric with respect to the x-axis cannot be a function.
Symmetric with
So this is this example actually. This example works here. Yeah, this is gonna fail the vertical line test. So this is false.
relation symmetric cannot be a function. Just by answer. Isn't that true?
Oh yeah, actually, yeah, my bad. Yeah, it's not a function. If that's so, if it's saying it's not, then this is true.
Yeah.
Because it'll fail the vertical line test. You have to be careful with the wordings. I don't think they're gonna ask you true and false questions on a math exam, but I'm not sure. Could though, could. I don't know. If it's in the book, you never know. 73. Which function is continuous? So continuous is something you cannot count in your hand, okay?
Yeah.
Like the number of people in the class is discrete, that is not continuous, but your height is continuous. The amount of time it takes you to read a book, continuous, okay? And let's look at these.
Just numbers exceeding 10? Like
no, like decimals. Continuous, you can't have decimals. Decimals are good for continuous.
Oh, okay. Yeah.
So for A, look at this number of children, you cannot have decimal. You cannot have like half a child. So this is discrete. This is not continuous.
Yeah. So
outdoor temperature as a function of time.
The outdoor temperature function of time, that could be continuous, could it not?
Yeah, that could be. Is there only one right answer here? So E is out because it says the number of soft drinks, right?
E, number of soft drinks, yeah.
That's out. What about B, C, and D?
The cost of US postage as a function of the weight. That could be continuous.
Yeah, all three of them could be continuous, actually.
Price of the stock as a function of time. Yeah, that could be continuous as well. So everything but A and B.
Yeah. Which function is not continuous?
Which functions?
Is this, see, this is very simple. Number of balls.
That is not
discrete, right? You cannot have a half a ball here. Like a decimal number of balls. So this is out. Everything else is good.
Yep.
Which function is decreasing? This means as x goes up, y is going down. Okay?
Outdoor, yeah. Outdoor temperature as a function.
I mean, what time? In the daytime, it's going to go up. At nighttime, it's going to go down.
The Dow Jones Industrial Average as a function. What the fuck? Air pressure and air atmosphere. Okay, that's definitely going up. D is definitely going up. Water pressure.
Yeah, it's not D any. I think it's C. Air pressure goes down as
Yeah.
as altitude goes up. Yeah, that's why planes
This is
fly.
really just testing our general knowledge.
Yeah. So, what is this? Who would know about this? I guess this is the stock prices. They're going up all the time, but
Yeah, no, that's gone up.
yeah. So the which cannot be classified as either increasing or decreasing. So for this, we're looking at a turning point.
Oh, sorry. What was the answer for number 75?
We went with the air pressure question.
Air pressure, yeah. C.
76, is this classified as either increasing or decreasing?
Weight of a lead brick or a lead the volume.
It's gonna go up all the time.
Yeah.
Yeah.
Got it. That's increasing. The strength of a radio signal is a function of distance.
So we're just
from the
looking at
transmitter.
what
That's
changes.
Gonna go down.
Yeah, exactly. A is gonna
That's
change.
Gonna go down.
B is gonna change. What about C?
Time of travel from Buffalo to Syracuse as a function. Driving speed.
Yeah, that's gonna
just
fluctuate,
stay
right?
constant. Isn't that constant?
Yeah,
that's time travel. It's not.
No, the
as a
time will be
function.
2 hours if you drive like 100 kilometers or miles per hour, or it'll be 3 hours. It fluctuates.
Area. Yeah. I don't know. Yeah, some of these are.
So looking at which one does not fluctuate or does not change. Air is gonna change when the side length goes up. Right, so it's not D either.
So yeah.
I think it's A actually. The weight of a lead brick. Would the weight of a brick change ever? No, right? Height of a pendulum would change, right? If time equals 1, it might be down here, and then 8 at 2, it might be up there. Yeah?
Swinging pendulum. Yeah, definitely.
So the height can fluctuate. What about the weight of a brick? I think that's gonna change. Actually,
Yeah,
I don't know.
I doubt that.
Volume. If the volume of a brick goes up, would the weight change? I think it's between A and E.
It definitely wouldn't be E though.
But E is the only one where there's a turning point, and we know function is not doing either when there's a turning point.
Yeah, but it still could change at different parts.
Yeah, if you're looking at one spot in time, what if you look at the entire thing though?
Yeah, true.
Then it would change, right? Area is always gonna go up
Mhm.
as the side length goes up, but here, this is gonna turn, I think it's E.
So E?
Yeah, because there's a turning point, simply because there's a turning point, which means the slope is 0 at the bottom.
Yeah. 76. Is that everything? Yeah. All right. That's it.
Alrighty. I'll see you when I see you next time, okay?
Yeah, appreciate it. Thank you.
The video will be on YouTube. I think your mom has the channel link, so just look for Pre-Calc.
Okay. Thank you.
Right. See you later. Bye-bye.